content, that's not appropriate for a school that you elected to come to. Right? Like, I get it. If you're just at like a normal school, you might not want to be there. Right? But like this is Phoenix. This is different. So this isn't really a conversation I normally have to have with this class. But if for some reason, and just because you were right next door, so I'll fill you in, and your classmates will probably be murmuring about it later, because that's probably the meanest I've gotten all year. If you find yourself not starting on a problem or what we're doing in class until I walk around the room and see that your page is blank, or until if you just are sitting there waiting to see, can I get away without doing this, you're probably in the wrong class. Right? If you do not want to engage in the mathematics, you're probably in the wrong class. So if that's you, if you're reluctant and not wanting to do the math and not wanting to do your homework, we should probably talk. Okay? Because my issue that I was having with the last class is that there were certain individuals who were just sitting doing nothing until I directly say Mallory, why is your paper blank? George, why don't you have this problem? And that's frustrating. That shouldn't be, we're 3 weeks in, we're almost a month into the school year. We should have this figured out by now. So all that to say, let's have a better class than the last class did. And it's not like class was bad. It's just some of them were being really lazy and not wanting to engage with the work that we were doing, which you're here because you want to be here. That's what you guys voted. Right? Yeah, test tomorrow, so there's no weekend homework or anything like that. So you'll notice now the assignment board over there for tomorrow says chapter mastery, no homework. So if you want to go ahead and fill in your plan book, no homework for tomorrow, you can. Then you can wait till tomorrow. But when you come in here, it'll just be get out a pencil and take the mastery. Yeah. So content that will be on the mastery. Perimeter and area of the shapes we've been working with. So parallelograms, trapezoids, and triangles. I probably won't hit you with anything really easy like squares, rectangles. You guys should be familiar with those already. So perimeter area of those shapes with numbers that aren't terrible. I won't make crazy decimals or anything. Simple probabilities. So bag of marbles or bag of blocks or claw machine sort of problems. Nothing complicated. I don't know if I'm even going to put any compound probabilities, or situations. Yeah, those actually aren't that bad. You just have to know how to add the fractions. I don't think there's really anything else. Yeah, it's not huge. Because especially if we're only budgeting one day, I want to make sure that we have time to get done. 2-on-1 is meant to be a 2-day lesson, but it won't be for us because we're the compressed accelerated class, right? So on the same note as if you find yourself not wanting to do math, this probably isn't the class for you. We're going faster. So your homework is 8 through 17, but pick 6 of them, right? Don't do the whole thing. I did the whole thing. It took me a while. So there are problems on there that are great to do tonight in prep for the mastery, but I'm not collecting that tomorrow because I'd rather just keep it with your chapter 2 work. So tomorrow I'll collect 1, 2, 3, and 1, 2, 7, 8, that combined homework thing. Any other general questions about mastery tomorrow, homework collection, any of that? 9. Big 9. Yeah. All right. So, yeah. Huh? You just choose 6 of the problems, whatever 6 you want to go. Great, wonderful. You're awesome. You're ahead. So now, the common temptation for 7th graders when told pick 6 of the problems, scan through and look at what you think is easiest, right? But do you think that's the best prep for the mastery or getting better at the skills that you're not great at? As we talk about multiple intelligences and developing those things that we're weak at. So it's up to you what 6 you choose, but I would encourage you, don't just choose the 6 that you think are easiest. If there's some skills on there that you feel like you need to practice those. Make your time helpful or worthwhile as opposed to just I just did some problems. Anyone feel like reading? By the way, if we're taking notes, you can abbreviate this if you want. Frac dec. So we are turning fractions into decimals, so you can abbreviate your notes, frac dec if you want. Would you like to read for us?
Yes.
All right, go ahead. That whole paragraph, please.
In previous lessons, you explored different representations of portions, parts, fractions represented as fractions and as decimals, and he went back and forth between the representations.
Sorry.
While fractions are written in a common format, that is, as the quotient a over b, where a and b are integers, there are decimal representations of two types, terminating and repeating. Why does this happen? In this lesson, you will work with your team to determine what makes some decimals terminate and some repeat.
So we already talked about this a little bit last chapter, terminating versus repeating decimals, right? We looked at a couple situations of those fancy repeating decimals. Correct me if I'm wrong, but like we did like the sevenths, right? Looking at the weird. I'm seriously asking the question because I can't remember if we did this with this class or not. Okay, so there's some really cool relationships with the repeating decimals. But one of the worst things we do as educators is when we start doing this with you, we have you long divide. And long divide is like gross in a way. I mean, seriously, like if somebody comes up to me and they're like, I'll offer you $10 to do my long division homework, I would tell them that wasn't enough money. Like, I don't want to do long division, and hopefully we don't need to, right? Let's make strategies so that we can avoid that. So, other quick announcement, as you notice, my two screens are identical right now. I fixed my Smart Ink, so now I can actually write on the bottom board while the textbook is up. So as we do this and I write on here, I will take a snapshot of what's on the screen. So if you're still writing, it's up on the TV as we move on in the textbook down here. So that's my point of using the two screens, not just to be like fancy. And like here, this is because when I work, I want two different screens to have more space. But up there, it's so if you're taking notes or if you were in the bathroom or whatever else, it's up on the TV. So TV is what just happened. Smartboard's what currently is happening. So 2/3 versus 3/4, right? I think a lot of us could pretty quickly say like, well, yeah, one of these is repeating, one of these is terminating, because we're pretty familiar with at least the 3/4. But how does this like really work as like the idea of what we're doing? So I want you guys to kind of think about this for a minute. If you have two of something, pizzas, cookies, whatever, and you want to split it to 3 people, or you have 3 of something, and you want to split those among 4 people, like, what is the strategy that you could use, especially like if we're talking about pizzas, to make this job easier? Talk with your group really quickly. Like, when we talk about division, like, what really is that? Like, what are we doing? As opposed to like long divide and you know how to work with the numbers, like conceptually, what are we doing? So talk to each other for like a minute, a couple minutes. First of all, where do you find this? Have we talked? You're good. Wrap up. You were very very into whatever you guys were talking. 1/2 of an apple. Have we? I love it. I really do love the passion. Have we talked about the portions web yet? In the book, it's got so yeah. In the book, it's got all the arrows and the. For me, I want to make your life easier, right? All you got to draw is the triangle. You don't have to draw all the arrows and different things like that. The portions web is just a graphic organizer. Graphics mean we draw it, right? These things are all related. They're all equal. So here's a picture, right? I'm not just trying to make it look like a face. 2 out of 3. Now, I could also draw an alternative picture. 1 object, 2 of 3 pieces shaded. Both of these mean the same thing. 2/3 or 2 out of 3. Now, if we go to look at the decimal or the percent for this value, a lot of what we've been doing so far is turn your denominator into 100. However, Savannah says. Braylon? Sure, yeah, if you know.
You have to divide, so you have to divide 2 by 3. Yeah.
Okay, so I got confused when you were saying you have to divide. You could divide 2 by 3. If we had a calculator, take 2, divide by 3, get your answer. But if we don't have a calculator, right, our strategy is try to turn this into 100. 3 into 100. Connor?
Divide 3 by 100.
Ooh, close.
100 by 3.
Quinn?
We could take 3, or you could take the 2/3 and divide it by, times it by something like, say, like 100. And then
Okay.
you divide it back, and you take the number that was in the, that was in the
Okay.
100, so it's combined.
Make things bigger, then bring it back down. Yeah, I like that strategy.
100 divided by 3.
We here to figure out this multiplier, we can go 100 divided by 3. If we do that, though,
It turns into it's messy. It gets messy.
the multiplier comes up to be a repeating decimal. That doesn't work all that well. We're going to come back to that one. 2/3 we're going to come back to. Let's make a portions web for 3/4 real quick, because this one's easier. So make a triangle, and in the middle, whatever picture you want to represent for 3/4, go ahead and do that. I like the little circles or pizzas or whatever you want to talk about. But now, can this still represent 3/4?
No. Yes.
Yes or no, depending on how you look at
It
it.
was like 1/4.
It could be 1/4 is shaded, or it could be 3/4 is not.
No one knows that.
Right? So this could represent 3/4. If these are pizzas and this is meat toppings, that means 3/4 of the pizzas are vegetarian, right? Or whatever you want to say. My wife's vegetarian, so always on my mind. Can I turn 4 into 100 easily? Yeah. What's my multiplier? 25. So top becomes 75, which then when I do the decimal, 75 hundredths. And then when I do the percent, I know that if it's over 100, that's my percent. So that portion's web is real easy. Quinn, you with me? Can you pull your arms out of your shirt, please? Thank you very much. Appropriate seventh grade behaviors, right? You got this down. So, 1/9, right? 1/9. If we write it in the, somebody yesterday asked me, can I still use the old-fashioned division symbol? Because we don't use X for multiplication anymore. We can still totally use this division symbol. This is also a division symbol. I'll make sure that we clear that up. The fraction bar is a division symbol. It's just another one that we can use. 1 divided by 9. When we long divide, and this is like, there's stories of like Einstein or different mathematicians who their teachers don't waste their time. So if your math teacher said, okay, divide 1 by 9 until you find an end, you'll be doing it forever. Your teacher's evil. Because your first division will get you a 1. And then you do it again and you get a 1. And you do it again and you get a 1. And you do it again and you get a 1. So we as mathematicians started to write this either with the ellipse or with the repetend. Right? But what if it's not so easy as like small number, big number, and like we start to learn some tricks, especially like with the ninths, it just repeats whatever's on top. So there's 2 ninths, it'd be 0.2 repeating, 3 ninths, 0.3 repeating. But what about like 13 divided by 5? Right? So we go out to dinner, right? Let's say we go out to eat and we've got the 7th grade teaching team except for Mrs. Goldring because she decided to go cook for her family instead. So we have all 5 of us out. We order an order of cheese sticks. They bring it, and immediately we have a dilemma. There are 13 cheese sticks in the order, like mozzarella sticks, right? Which we're nice, right? We want to make sure everyone gets a fair, equal amount. So the first thing we do, you say, okay, you get one, 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 and everybody now has 2, but we have 3 left over. what can we do? You're going to talk with your team. What can we do to easily take these 3 cheese sticks and fairly distribute them to all 5 people? Talk with your team. Five people eating.
I think that
Yeah, they
I mean, they would 2 points.
You might be mad that they're not letting you do that, but don't say shut up. And then write something to represent the idea you guys are trying. Are you taking the 3 sticks and dividing them by 5? Are you going to take the 3 sticks and make them more pieces? Are we going to take the 3 sticks and throw one away? That's not an option. That was a joke. Because last year somebody said, "Well, that's easy. Cut them all in half and throw half away, and then everyone gets half more." Right? Like that's not an option. We cannot just get rid of some of it. You can't give any to your server. Not an option either. They can't take food tips. They probably wouldn't anyways. Anyone have an idea? What if somebody eats all of them, then they're mean. They're not our friend anymore. But that's not the situation. We're all real hungry because we're teachers. And, we don't have much money because we're teachers. You don't know that.
Why would you just eat 2 cheese sticks?
Because I have a free appetizer. Mallory, what can I do?
You can cut the last 3 into this.
So Mallory says, if I cut the last 3 into fifths, so if I right now I have 1, 2, 3, 4, 15. Right, okay, so now I have 15 pieces. And really that is 15 what? 15 fifths. Right, because this still needs to equal 3. So I have 3 cheese sticks. Okay, Mallory, what do I do now? Oh, yeah, 5 people, right? So person 1, person 2, person 3, person 4, person 5. Everybody gets 3 more fifths. You want to see this done? Here we go. Check it. There's your 13. Everybody gets 1. Everybody gets another. The last 3, now we actually don't just divide them by 5. We divide them into tenths. So we cut them all up into tenths if we were doing long division. Right now, here's the thing. In long division, in decimal place values, there's no other way to cut things apart than base 10. Right? Either tenths, hundredths, thousandths, 100,000ths, whatever. But Mallory didn't use division and decimals. She used fraction work and realized, well, shoot, I can just do fifths. That works. But if we did long division, we'd be stuck doing this. And then we redistribute all the little pieces. And the cheese sticks are cold now, and no one wants them anyways.
Wouldn't they start as being cold?
Well, I was talking about like mozzarella sticks, right? Like the deep fried, real unhealthy. You've never been out with a group of teachers that just like needs to not talk about their students or anything and just dives into a problem? Because I heard Braylon made the very legitimate question of like, well, who would put this much work into 3 cheese sticks? It's more the conceptual idea of like, is there a way to do this fairly? Because there are situations that we encounter that like to do it fairly is going to take a lot of work, or it may not even be possible. So really what we just did, and most of you will be pretty familiar with this, set up on your paper, and I heard people asking like, shouldn't we be writing or something? Set up 13 over 5, but not as long division. Reminder though, because some people have never heard this, if you want to go to long division, the numerator goes inside, the denominator is knocking on the door. That's the trick. Numerator goes inside, denominator is outside, like knocking on the door. But if we don't long divide, we don't need to remember that. How many 5s can actually be pulled out of 13? Anyway, 2, and I'm left with 3. All we really just did was make it a mixed number from an improper fraction. Or at least that's what Mallory just did. Now, in the video they showed us, they ended up with 6/10. Same thing. So, let's take this idea, but now we have 2 pizzas. Right, and we're going to skip all this. We have 2 pizzas. Right, and we could do that same idea. I'm trying to move quickly today because I'd also like to let you start your homework. We could do that same idea with 3/4. Right, we have 3 objects and we're going to split it to 4 people. We can cut into pieces. If we're stuck with cutting into tenths, we then actually end up having to cut into hundredths. So if we tried that skill here, we'd end up giving everybody 7/10. But then we hit a point where like it doesn't work, and we have to cut the tenths into tenths again, which makes hundredth. This gets really annoying. So we're not going to physically do that and write it out because I don't want to make us do that. So we're going to look at this. You have 2 of something physical. These bars, and I did not print this page, so I think this is dumb. Draw something on your paper that you have 2 of. They can be 2 big rectangles of the same size. They can be 2 circles of the same size. I don't really care, but make it easy to split up. And I'm probably going to cheat. I keep talking about pizzas. And then we're going to have 3 people, right? 2 things divided into 3 people. So let's just call these people A, B, C. Easy as so if we're working in our American system of mathematics, we got to split things into tenths, right? We're going to talk decimals. So if I split into tenths on my pizza, it's actually kind of hard because I can't do quarters. Ten slices. So I start, now I asked Domino's, right? They normally cut into 8 pieces, but I asked Domino's, make me 10 pieces, right? So I want the pizza in tenths. So I initially give person A, person B, person C. Person A, person B, person C. Person A, person B, person C. Snap. Person A. Now it's okay, right? Because we have another pizza. But right now, everyone has gotten 3/10 except for A. They've gotten 4/10. Right? So we move on to the next pizza. So since person A already got another slice, we're going to start with person B. And then C. Right? To be fair. We're not going to give A another slice. Now everyone's got 4 slices. And we keep going, right? Because we're going to keep eating. Person A, person B, person C. Person A, person B, person C. Snap. So those 2 pizza slices, I now do something fancy with. And if you've ever tried to fit big pizza slices onto a plate, you will know what I'm going to talk about. I point one up, and I point one down. And I've ever done this to fit pizza on your... So what is this amount right now? Those 2 slices that were left over, how much is that? 2/10, right? So that's a tenth, that's a tenth, 2/10. Can I split that between A, B, C right now as it is? No. But what if I cut each tenth? Now, you're going to have to assume that these pieces are the same size, but... I made you little tiny pizza spheres, right? Because I cut each of those slices into tenths. So now, instead of being 2/10, what we have are 20 100ths. There isn't, right? Well, aside from that, I cut a bunch, but there is no difference. Same amount of pizza. And I do the same thing again. ABC, 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 ABC. Crap. We still end up with 2 left over.
You have to cut them smaller.
Because, right, think about it. 3 people, if everybody gets 6 more of these, I use up 18 of them. And I end up left with 2 hundredths. So I slice up those hundredths into tenths, and I get 20 thousandths. I have 20 again. Am I ever going to get out of this problem? No! This is the issue with decimals. This is the issue with America. We have created a system that is very fixed. Right? We are locked in base 10, except when we work with inches or feet or miles or volume or time or essentially anything except for numbers, right? So over here, all of our measurements that we take essentially have no base, right? Inches to feet, feet to meters or yards. If we stick American, we'll go yards and have a base 3. And then how many feet in a mile? Who even knows how many feet are in a mile? 5 tomatoes, 5,280. 5 tomato, 5280. You remember 5 tomato? That's your feet in a mile. The problem with dividing certain fractions and actually doing the division, you'll never finish. You'll always continue to cut your pieces smaller, and you'll always continue to have leftovers. No, like you literally have to go forever. So here's this whole concept that I don't know if we discussed with this class enough, but I have a really great video that I want to show you guys about it. In order for 0.99999 repeating forever to not equal 1, you'd have to tell me why it doesn't. So can anyone so George immediately said well, it doesn't. George, what's your thought?
Okay, so you're always gonna have that one.
Great.
If you have 9, you're always gonna have 1 left over in the tenths. That's not 1. Then if you keep going, it's even smaller. If there's even that smaller one, if you keep going on forever, and there's that one thing that's not 1.
Okay, so what if I go to the last place, right? The infinite decimal place that I can't actually get to, but if I go there and I drop in another 1. What happens? Connor? All the way back up to 1.
Yes.
Every single 9 carries a 1. Back to the 9 above it. I got a sweet way back. I keep moving that because I keep kicking it. I don't think that's a good location. Sorry. I had this video pulled up, but then I closed it accidentally.
Oh yeah, we watched this the other day, didn't we?
Well, in foundations, I think. So imagine each of these bricks is a 0.9. Okay? So hold on. Now I'm only using this video because he goes with it and follows it. Watch. 99999999999. We're in the millionths place, the billionths, the trillionths, the quadrillions, the quintillions, the septillions, the octillions, the nonillions. After that, it gets really complicated. Yeah, it gets real weird. So we go all the way. Now, if you want to talk about the math of like the actual landscaping of why this works, come talk to me because I've got it figured out and it's actually really, really sweet and I want to try this. So we make it to the infinite decimal place. Just watch it. Stop. Hold on. I tried to pause and I didn't catch it. When you make it to the infinite decimal place and you give it one more like octa, omni, milli, whatever spot we're in, every 9 then turns into a 10, which carries the 1, which then turns that 9 into a 10. Now, unfortunately, they don't actually make it all the way. It gets jammed up right here because one of the bricks wasn't quite straight. But that's the idea, right? Behind that whole repeating decimals. So, by the way, 2/3 is 0.6 repeating if you're not aware of that yet. I think a lot of us know the thirds already. We got time. Let's look at 2/5. Katrina works at the fraction factory. Yeah, you know, real place, of course. And she's been given the fraction 20/33. Now, I promise this is going to help you with your homework, so we want to put some effort into this. Now, Katrina's been told a couple different rules since working at the fraction factory. Like, 2/3 she knows repeats. Knows that doesn't end, it keeps going. It's 0.6 repeating. She also knows that 2/9 doesn't end either, and that actually repeats 0.2 forever. So she starts to wonder, is there a way to use that idea to help with 20/33? Take 2 minutes with your group, talk about it, see if there's anything that you can figure out to use some of the rules that we know to help convert that to a decimal. Now, you can check out her long division if you want. That's totally fine. You can do the long division if you want, but I refuse. In math, we use the word approximately. We just had that conversation. Can I turn 33 into 9?
No.
Not easily, at least.
Because it's 34, never mind.
Could I turn it into 99?
Yeah. Can't turn 20.
What multiplication would happen here? Please put this work on your paper if you don't have it. And we get 60. Now, if we had 60 over 100, wonderful, that'd be easy. But we don't. Now, she starts the long division, and Katrina finds out the first 2 numbers are 0.60. She's not done, but those are her first 2 numbers. Her next 2 numbers her next two numbers. And by that point, she's tired of long dividing. And she just goes ahead and throws this up. She thinks, well, if this has happened 3 times already around, it's probably going to keep happening. Now, you ready to get your mind blown? Because I don't know if we're at the level to understand this yet, but I think we are. We can make a lot of rules, and not like rules isn't a bad thing, but rules that will help us like not even have to think. We just, oh yeah, that turns into this. Write down in your paper 2/3. And the fact that it equals 0.6 repeating. And then we're going to say that is actually going to be equal to some value x. We're going to start to work with x as a variable. Now, I was having a discussion with Dave. You guys might as well get to know Dave. Dave's one of my closest friends, and he's also a 7th grade math teacher, 7th and 8th grade. So we talk about these things a lot. We were debating whether it's far enough through the year to present you guys with this. And I think we can. If I wanted to get some numbers in front of the decimal place, right? That 0 looks kind of sad. I can do anything I want to an equation as long as I do it to both sides. So let's go ahead and get some numbers in front of that decimal place by multiplying by 100. Because that'll just move the decimal place essentially. And that becomes 100x equal to 66. Sorry, I tried to drop that in the wrong place. 0.6, so that's still repeating. Can anyone figure out what we can do on both sides that turns my repeating decimal into just a number? Not a repeating decimal, a terminating number. Connor? We could potentially like add a repeating decimal, but would we add point? Well, but I don't need all of those 4s. I actually only need 1 4 at the very end. Right? Didn't we just say with that brick problem, like I need 1 1 at the very end? Here I would need 1 4 at the very end, and then that changes all of the other ones because it carries. So I don't actually need 0.4 repeating. No, so think about it. So if the last, quote unquote, the last 6 turns into 10, it can't. It turns into 0. Or yeah, sorry. So that carry doesn't work right. Crap. That totally falls apart. Well, they'd be turning into 7s. So I'd need like 0.33333, I think. But then a 4 at the very end. That gets really complicated. I want to get rid of this section, right? I want to get rid of 0.6 repeating. I want to get rid of x. If I subtract x from this side, what do I subtract from this side? 0.6 repeating, because that's x, right? I also subtract x, but that is 0.6 repeating. So wait, how many x do I now have? If I had 100x, I subtract 1x. I got 99 problem. No, sorry, I got 99x. That about got dangerous there. And that's equal to, oh. How do I get x by itself? What do I need to get rid of? To get the x by itself, I got to get rid of the 99. It's being multiplied. Sorry, I got to wrap this up because you have another class to go to. So we divide by 99, and that fraction actually becomes 66 over 99. Now, we could do the same thing starting with, hold up, we can do the same thing with this. If we make the 0.20 repeating, we can do the same thing with any repeating number. We can do the same strategy. So this would actually turn into 20 over 99. When we do that work too. Now hold up. Here's where it gets crazy. Give me 30 more seconds. So if I wanted to do 0.456 repeating, anybody have an idea of what fraction that will become?
9.
It repeats however many nines you have. 3 nines repeats 3 digits. 2 nines repeats 2 digits. So here's what it is in your homework, though. And if you need help, talk to me tomorrow. I think it's like 5 over 99. How do I make 5 into 2 digits? Can I put a 0 over here? No. Get out of here. Have a great night, guys.
Mr. Watson. Exactly.
I have to clean up brains now that you guys are leaving. Mind blown.